Magellanic Clouds. You have the Large Magellanic Cloud and the Small Magellanic Cloud, and that's not a cloud, that's a comet. It's just a nice picture, we have to have a comet in there. And these are two little dwarf galaxies. They've each got about 100th the mass of our galaxy, and they're orbiting our galaxy about once every 2 billion years. And the Large Magellanic Cloud is the closer one. It's about 170,000 light years away. The Small Magellanic one's about 30,000 light years further. So they're way out beyond the stellar disk. But they're still responding to the dark matter around our galaxy and the mass of our galaxy, even though they're way beyond that disk. And what's happening is that they're kind of getting disintegrated. If we look closely at their morphologies, first of all, they're not ball-shaped, they're not elliptical, they're not spiral, they're completely distorted. And the next thing you notice is that they're very blue. They've got loads of star formation going on and huge amounts of nebulae around them, particularly the LMC. And these little galaxies are getting shredded by the gravity of our galaxy. Our galaxy dominates. So what happens is gradually it's pulling stars off. And in fact, if you track the path of the Magellanic Clouds, you can see it very clearly in radio wave bands. Here's an all-sky picture of our galaxy that's been somewhat unwrapped. You can see the Magellanic Clouds there and there. If you look in the radio, you find they're trailing a long stream, so imagine that looping round the galaxy, of neutral hydrogen gas. That's all been stripped out and poured out of these galaxies and embedded within our stars. And so what's happening is that these two galaxies, as they orbit ours, are slowly disintegrating. Materials, they're leaving this huge stream of material in their wake. They won't last forever. They're going to get completely torn apart by the gravity of our galaxy. And they're not the only ones. These are the two most obvious in the sky. The closest one to us was only discovered in 1994, and it was difficult to detect precisely because it is close. It's called SAGDEG, or the Sagittarius Dwarf Elliptical Galaxy. It's difficult to find because it's so close, so it's diffuse and it's spread out over a large part of the sky. So to see that as a coherent object is quite difficult. It's also on the other side of the centre of our galaxy. If we're there, it's right on the other side. And again, it's got these fantastic streams of tails. It's, again, being completely disintegrated. And this is quite close. This is like a third of the distance out to the nearest of the Magellanic Clouds. It's only 50,000 light years out. It's really getting torn apart by the dark matter halo of our galaxy. And therefore, it's a very good, seeing what happens to that, is a very good tracer of the mass distribution in our galaxy. And it's leaving these wonderful tidal tails. So it's clear, if you've got a dwarf galaxy in orbit around a large galaxy, the dwarf galaxy comes off worse. Well, that's no big surprise, really, when you think of the relative distribution of the masses. However, there is an